Good evening, everyone. Thank you so much for taking the time out of your busy schedules to be with us this evening. I want to give a quick shout out to Reese Huntington and the team at Shark Club for affording me the opportunity to be here with you this evening. And so let's give it up for them. So I started doing this when I was about 9 years old. My father explained to me that you can find fossilized shark's teeth on the beach. And so naturally, I went looking for one. I found one and I thought to myself, why aren't more people going crazy over this? Turns out I wasn't the only one. But nonetheless, this was an addiction that has no cure. So, if you were with us last time, we talked at length about several of the shark species that we find throughout the Lowcountry. We also touched on some geologic context that we use to understand our fossil record and some evolutionary history to go along with that. Today, we're going to talk briefly about some shark's teeth. We're going to briefly touch on some highlights from last time. And we are also going to review some concepts that we are going to use to carry over into today's discussion. So, we'll start off by saying that much of the geologic history of South Carolina was formed by river processes. So this makes studying the geology of the Lowcountry very convoluted. Why? Because we do not have a great supply of consolidated rock to study. All of the sediments that we use to understand the nature of South Carolina's past is going to consist of sands, muds, clays, fine sediments, unconsolidated sediments. And so these sediments are highly susceptible to erosion and river processes as they carve through the landscape. If you were with us last time, you might recognize this figure here. This is a depiction of, generally speaking, some of the more prevalent formations that we find throughout the Lowcountry. We start off with the 10 Mile Hill Formation. This is a Pleistocene age deposit, which is an Ice Age deposit, which consists of lag. Lag is river winnowed material. So this is material that has been eroded by rivers and deposited by rivers. You're going to find bone in this layer. Whalebone, you will find dugong, which is a species similar to a manatee. The dugongs, by the way, are still extant off the coast of Southeast Asia. Beneath the 10 Mile Hill, we get into what's known as the Chandler Bridge Formation. The Chandler Bridge is an Oligocene formation, which consists of very fine clays and sands. And so the shark's teeth and the fossil material that we find in this layer in particular are going to be very well preserved. You will oftentimes find shark's teeth in this layer that are just as sharp as the day the shark lost them, which is very exciting for us collectors because we get to find these teeth in very good condition. So, going beneath the Chandler Bridge, we come into contact with the Ashley River Formation. Once we go beneath the Ashley River Formation, which is a limestone base, we find that the fossil material here becomes incredibly sparse. And so we do not find a whole lot of fossil material below this contact zone. This goes without saying, we kind of touched on this before already, but the level of preservation depends on the environment and the conditions that are found therein. And so when we're dealing with fine sediments, clays, sands, muds, this means that fossil material, teeth, bone, are buried rapidly to prevent scavengers from destroying them. And this also represents a very low oxygen environment, that is to say, an anoxic environment. And the mineralogy that we find throughout the Lowcountry, and anywhere you find fossils in general, is going to be solely responsible for the colorations that we see in the fossils that we find. This is contrary to the popular belief that the darker a fossil, that is like black, for example, a lot of the shark's teeth that you find on the beaches around here are going to be black in color, are older. That is incorrect, simply, but it is easy to see why one would arrive at that conclusion. But we find shark's teeth throughout this zone of varying colorations. You get every color of the rainbow, and if you were with us last time, we took a little bit of a look at that. And The last concept, or the last thing that I really want to share here before we move on, is to get out and explore. Get out in the field. You can derive substantial value from reading about these things in a textbook, but I would argue that you can derive significantly more value from getting your hands dirty. And so much of the knowledge that I've acquired in doing this type of thing, I've got from just going out and just parking in random neighborhoods and walking into random creeks, and usually filled with trash. But I have found that the dirtier the creek and the more trash there is, the better the shark's teeth. Go figure. The entirety of South Carolina's fossil record spans all the way back to the Cretaceous, which is dinosaur era, all the way up to the end of the Pleistocene. So this covers a broad spectrum of habitat, all the way from marine environments to terrestrial. And we are going to talk, like I said before, briefly about some of the shark species that we find in the low country. And we are also going to take a closer look at some of the Ice Age terrestrial mammals that we find throughout our region. So, one of the highlights that we looked at last time was the Ototus angustides. This is the grandfather to the Meg, so to speak. It is one of the evolutionary precursors to the Megalodon. And they have two primary distinguishing characteristics, one of which is going to be the presence of these side cusps here. You'll notice that these become less and less pronounced as you move across the lineage eventually to Megalodon. The reason for this is believed to be because the adaptation of these side cusps that we also see on modern species like the sand tiger, for example, are thought to be used as a grabbing mechanism for grabbing hold of small fish, because small fish can be very tricky to catch and grab hold of. And so the thought is that as these sharks grew to eat larger and larger food items, i.e. whales, porpoises, this became sort of a vestigial trait and was no longer needed. The other primary characteristic here is that you'll notice they have very thick root structures. The problem with some of these earlier sharks, and the angustides in particular here, is their thick root structures, their teeth were very firmly planted in the jaw. And so when your teeth are very firmly planted in the jaw, you are not cycling through teeth very rapidly, which means you are reusing the same teeth over and over again. And so we find the angustidans oftentimes dull, mangled, and damaged from feeding. Their maximum length was around 50 feet long. The way that we know this is from looking simply at their teeth. Every inch on a shark's tooth measured down the slant from the tip of the root here to the tip of the blade roughly translates to about 10 foot on a shark. And this goes for every shark species regardless, across the board. But a 5-inch angustidens is exceedingly rare. Finding a 4-inch angustidens intact is like finding a unicorn in and of itself. But the angustidens was not without contenders during the Oligocene. We find toothed dolphins, porpoises, and cetaceans. And the Ankyloryza, being the largest of these, you can see here at the top, is an example of an Ankyloryza jaw. This species, along with others, are classified under the wapitid or wipatiid dolphins and porpoises. And the primary distinguishing characteristic of wapitids or wipatiids is that they have what is referred to as a heterodont dentition. This is simply to say differently shaped. And so the teeth towards the posterior of their jaw are going to be double-rooted and partially serrated, while the teeth towards the anterior of the jaw are going to be more conical in shape and protruding from the jaw, like you can observe here in this background picture. But Wapitids and Wapatiids are a broad taxa, and studying early cetaceans, when you are studying early cetaceans, the low country of South Carolina is a prime locality for doing so. If you are ever interested in the study of these creatures in particular, I would highly, highly encourage you to check out the Mace Brown Museum of Natural History in downtown Charleston. It is affiliated with the College of Charleston, and they have an amazing collection of these species and others. One problem, though, with these is that it is nearly impossible to determine the species from which a cetacean fossil originated without having the teeth present in their sockets. And so that is an example like you'll see here. I do not know what species this is, simply because of the absence of their teeth. And so that is one fundamental thing to keep in mind as we are studying these animals. Of course, we arrive at the Megalodon, moving through time. The Ototus angustidens max length was approximately 70 to 75 feet. And so this means that their teeth maxed out around 7 to 7.5 inches, which is a whopper of a tooth. Okay, this is the undisputed heavyweight champion of sharks. Their geographic distribution is global. Megalodon teeth have been found in various concentrations on every single continent except for Antarctica. I don't blame them. Antarctica's too cold, ain't nobody got time for that. There are a few theories on the Megalodon extinction in circulation. The most prevailing theory, as far as I'm concerned, is that these sharks simply hunted whales to the point where they could no longer sustain their own populations. They were an apex predator. And as they fed on whales, their teeth are oftentimes found broken or fragmented. And we see this often. 80 to 85% of these teeth that we find are going to be broken in some way. The most common breakage plane that we find is straight down the middle. And we also see evidence of these predation events from Megalodon on cetaceans. And so this is an example here of a section of flat bone, or from the rib cage of a whale. And you'll notice these gouge marks. This is quite exciting because this gives us a first-hand look at a predation event. Occasionally we do find pieces of these bones with the individual serration marks still preserved, frozen in time from a predation event that happened 2 to 5 million years ago. We find whale vertebrae. The whale vertebrae that we find range in size from a tennis ball all the way up to a 5-gallon drum. So these became very, very massive creatures themselves. We also find ear bones from whales. Oddly enough, pictured here at the top is a periodic or an external ear bone, and at the bottom here is a bulla or an internal ear bone. We have these similar bone structures in our ears as well, although ours are microscopic in comparison to these. But I am going to pass around a couple examples of cetacean fossils. This is a sperm whale tooth, and you'll notice the structure on the inside here. And I'll pass that around. And once it makes its way around, you can feel free to, whoever ends up with it, just come set it back up on the table. The other thing that I'll pass around here is a bulla, or an internal ear bone from the whale, and you can get that rolling on this side. And one of the first things you'll notice about the bulla is its sheer density. And so this is the primary reason why this fossil is believed to be so prevalent, that you'll find is one of the most prolific fossils that we find in the Low Country, simply because of their density and their ability to persist in the fossil record for this region. And just like that, we move on to some Ice Age mammals. So we have the Columbian mammoth here. So these mammoths were slightly larger than the woolly mammoths that we mostly think of when we think of mammoths. But they existed all the way from North Carolina, parts of Maryland, all the way through Florida. Florida, by the way, is a place that is known for its high concentration in Ice Age and Pleistocene fossils, and so that is a place, if you were interested in that in particular, is a place to definitely check out. One thing worth noting about the Columbian mammoths is this is a molar. This is the root structure here, and the chewing surface would be on this side. On this example, the chewing surface is mostly eroded away, and we oftentimes find problems with this species and their level of preservation. But one of the most common things that you'll see on Columbian mammoth teeth fossils is that they will be broken in half, straight down the center here. And so, as the animal matured, they would secrete an acid in their jaw that would cause the tooth to split in half and fall out of the jaw as it reached maturity, and they would replace it with a new molar. They did not cycle through teeth nearly as rapidly as sharks. They would go through a couple sets of molars throughout the span of their lives. But these are very exciting to find. We also have the American mastodon. And with the American mastodon, you'll notice that they have these rows of humps. And so the number of humps, the greater the number of humps, means that the more mature the animal was. And when you find them perfectly spiked like this, often means that the tooth probably did not erupt from the jaw and was not used during feeding. If it was used very little. But this example here is missing the root structure, which would have made up the other half of the tooth. But over time, as they would use their molars and grind food, they were herbivores as well, they would grind their teeth down flat. And so in the most used examples that we find of this species are going to be just like a flat plate. And it's very difficult to distinguish them at that point on the river bottom when everything is covered in muck. But finding these teeth are very, very exciting. Another species that we had during the Ice Age is going to be the giant beaver, or Castroides. And so you'll notice in the name, roids, this was a beaver on steroids. They were the size of a go-kart or a Volkswagen Bug, but this is a section of incisor from a Castroides giant beaver that I've personally found in the Low Country. And you'll notice here, there's a split here. The second half of this incisor would have protruded into the skull, and this is the chewing surface or the gnawing surface where the beaver was actually using it to gnaw on wood and so forth. We had giant ground sloths during the Ice Age in South Carolina. This is an example of one of their claw cores. These are very, very uncommon, but you'll find more of this material in Florida. There's a couple different species of these. One of them is the Jeffersoni, which was named after Thomas Jefferson, who helped describe one of the first early giant ground sloths in North America. But the one that we'll take a look at here is the Megatherium, and so you can see the actual size. This is a sloth, okay? Like, I mean, that's freaky. But their claw cores do actually get much larger than this. And on this example in particular, when I picked this up off the river bottom, this type of material is very susceptible to just withering away. And so one of the overarching themes with fossils in general is that as they are exposed to the elements over time, they are just disintegrating into sand. And once they are exposed to the elements, it's just a matter of time before this process happens. And so it is very important to save them. This is an example of a molar from one of these giant ground sloths. And there's really not much to speak on about these. They have this strange little V shape here, but overall, very hard to distinguish from a rib bone or a rock. And So these fossils in particular, you have to know what you're looking for to find one of these, and I'm sure that I've missed a few as I've been looking around. Very commonly, you'll find these broken straight down the middle as well. And so we have the three-toed horse in South Carolina. This horse did actually have 3 toes. I'm not doing much better. I have 4 toes. But before the Spanish brought horses to the Americas, we had them here as 3-toed horses. And so you'll notice that their teeth are really not that much different from the dentitions of modern horses, modern domesticated horses, if you will. But I will pass around an example of a 3-toed horse for you to check out. Over time, what would happen here is that they would grind these teeth down, and at the end of their lifetimes, these teeth would be just short little stubs. But they would start off 3.5, 4 inches in length sometimes, and over time, as they're grazing, they would just work them down like that. This is a metapodial, or a cannon bone as we refer to it. This is the leg bone, accompanied by the talus, which is towards the ankle. And so both of these specimens were found on the same day in different parts of the same river, but are not associated. They fit together, which was very exciting. But I have yet to find the digits. And so if you find the digits, let me know. That is not a pickup line. Another thing that's really cool about the Ice Age is that we had glyptodons. These are giant armadillos, again about the size of a go-kart or a Volkswagen Bug. Are you noticing a theme here? So this is an osteoderm, or a scoot, from the carapace of the glyptodon, and these are related to modern armadillos, but of course just much larger, and their carapace would be comprised of hundreds of these fixated together like a puzzle. It is cute, isn't it? This is the Tapirus viroensis. So this is the tapir. There he is over here. I wouldn't mind having one of these as a pet. I mean, we got raccoons, possums. How about a tapir? These animals are actually still extant in South America, and so you can find pictures of these still alive in South America. But at one point during the Ice Age, we had these in North America, and they had this. This is called a proboscis. Okay, we don't need to censor that, but this is a proboscis, which is a prehensile extension of the snout. That is to say, a short trunk. And they would use this adaptation to grab hold of palm fronds and other forms of vegetation that they would eat. And this is an example of a jaw section that I found from this animal. And their teeth are pretty cool. They would have little tusks at the end of their jaw. Normally, you'll find individual examples of their teeth. It is uncommon to find a section of their jaw, but like all of these Ice Age animals, Florida has a much higher abundance and concentration of them. And so in South Carolina, it is a treat to find these, but we did have them nonetheless. So finding these fossils is such an exciting time for me. I'm very passionate about it. But one of my preferred method, of course, is diving for these fossils. And so when we're diving, last time we discussed some challenges that we faced and some potential hazards associated with scuba diving. And I know we had a couple scuba divers here last time, but are there any more here with us tonight? Okay. We got a few more. You got to tell all your friends. Get access to the other 73% of the world, all right? But being affiliated with Shark Club here and at a fine institution like Coastal Carolina, we like to hone in on sustainability and how we can enjoy the environment and nature in a way that is environmentally conscious. And so a couple key takeaways here is going to be that Reese and I were discussing this earlier before the presentation, but sunscreen. And so I think you were saying that there's new legislation being passed
We're trying to, yeah.
in South Carolina for this. When you go to places like Hawaii, for example, their jurisdictions require that you apply a specific type of mineral sunscreen before entering into the ocean. This is different from the regular types of sunscreen that you can purchase anywhere at a store. Regular sunscreens have oils and other components, but specifically oils. Oxybenzone, extra credit right here. Extra credit, everyone. So, that's perfect.
I was just talking about this in my lecture. Oh my gosh. I could talk for hours.
Yeah. But no, it is very harmful to reef ecosystems in particular. These are fragile ecosystems, and the zooxanthellae that you'll find in coral reefs that uptake sunlight and undergo photosynthesis in order for the corals to have a food supply, it disrupts this system. And so the end result is you'll see coral bleaching. And this is a particularly horrible problem for places like the Great Barrier Reef. And that problem is rampant. But so we like to avoid that from happening. Another thing that we want to be careful of is to not disturb the substrate. This goes for plants and animals. And so, pictured up here at the top, this is a reef manta ray that I had the good fortune of diving with while I was in Kona back in December. This is a green sea turtle, or a hanu as the locals refer to it as. But these animals are illegal to touch because the oils from your skin can disrupt the biofilm that is present on the skin of these animals. And so these animals have a thin biofilm that is basically like their immune system. And so it protects them from infectious diseases and other things that they may come into contact with in the environment. So it shields them from that. And so we don't like to touch them. But if you have the opportunity to go here, which I would highly, highly encourage you to do, you will be told that you may not touch the manta rays, but the manta rays may touch you. That is the only way this is consensual, and I hope that we can agree that consent is important. And another thing that we like to touch on is plastics. I'm sure a lot of you have talked about microplastics in the environment and how harmful this is. And so in case you haven't, plastic does not biodegrade like a lot of other materials do when emptied into the environment. They photodegrade. And so they break into smaller and smaller pieces, and these tiny microscopic pieces, microplastics, are introduced into planktonic species. And once done so, they travel up the food chain into larger and larger organisms. The bluefin tuna is a prime example of this. And not only with microplastics, but also other harmful components like elements like methylmercury, for example. And so it is very important when eating some of these fish that you do not exceed the daily recommended portions, as this may cause adverse effects to your health. But again, very, very exciting place to go. If you ever have the opportunity to do so, I highly encourage you to do it. It may hurt your wallet, but the memories are priceless.